We are flying about 40 kilometers over one of the most violent worlds in the entire galaxy. Below us is a windswept world of extremes, where you could go from freezing nights to a burning storm in mere minutes, if not seconds. In this episode, we will cover the world of Iratis, one of the most extreme planets in the galaxy, covered with living, glowing rocks, and where storms are so common, flight is a necessity. Hi, and welcome to the Amanogawa. This is Admiral Timothy Richardson logging in. Today, on our never-ending quest to document the universe, we will be documenting the planet Iratis, a violent planet of red and green skies, shimmering rings, and freezing deserts. But why is this planet so violent, and how have the creatures here adapted to live here? Iratis is unique in that it orbits around a pulsar, a highly special type of star. Pulsars are basically the cores of ancient stars that have long since died. When they die, these stars literally burst into cosmic fireballs known as supernovas, destroying anything nearby. In fact, if such a supernova were to hit a colonized planet up to 50 light-years away, the effects could be devastating. The only thing that remains of the star depends on the size of said star. Larger stars collapse in on themselves and turn into black holes, while smaller ones turn into neutron stars. Pulsars are a special type of neutron star that rotates very, very fast, and spews magnetized particles from their poles, which gives them a lighthouse-like pulsing effect. As such, pulsars are very energetic stars. It is extremely rare that pulsars have any sort of planet orbiting them, let alone one that's able to sustain life. The supernovas that form them usually vaporize any planets the system had, but it is technically possible for planets to reform from the remains of the star and of the planets that the supernova destroyed. However, even if this does happen, the volatile nature of the star makes it very difficult for life to thrive around it. So, how is there life on Iratis? Well, for one thing, to protect its life forms, Iratis has an atmosphere that is both incredibly thick and composed of special molecules that break up the energy coming from its host star. These molecules break up the energetic rays Viridi-Pulto produces, thus keeping them from hitting and essentially vaporizing the local inhabitants. However, this generates a lot of heat towards the day side of the planet, causing the days to range anywhere from 50 degrees Celsius to well above the boiling point. However, the planet has a very slow rotation speed, around 5 to 6 times slower than Earth. As such, the nights get very, very cold, all the way down to about negative 90 degrees Celsius. This discrepancy between the two sides of the planet creates massive pressure differences, resulting in huge storms that ravage the planet's surface. Because of the intense storms that are frequent here, flight is a necessity for the native inhabitants. Being able to control where you land when the wind kicks up and blows you away is a significant survival advantage as opposed to just being stuck on the ground wherever the wind flops you. Fortunately for the inhabitants of Iratis, the thick atmosphere makes it significantly easier than on Earth. With Earth's creatures, flight is relatively rare, as it takes a lot of energy and resources given how thin our atmosphere is. That, and it's honestly not worth putting energy into it for the benefits it has compared to other features, such as being able to climb or run. If you can get it, it's great, but other features may be more worth putting time and energy into. However, on Iratis, the combination of the thick atmosphere and the violent storms make controlled flight not only a necessity, but also relatively easy to attain. On Earth, you either need to be significantly lighter than the average creature, or have a massive wingspan to be able to facilitate flight. In both cases, you will also need extremely strong muscles. Birds, for example, have hollow bones and a massive sternum to facilitate the huge muscles they need to fly. Bats, while not hollow-boned like birds, have massive wingspans compared to their relatively tiny body size to account for this. On Iratis, however, these features are not as necessary for flight. Something as dense as a penguin or as large as an ostrich could technically fly on this planet, given they had the right wing shapes. Despite the planet's significantly greater gravity than Earth, the atmosphere is dense enough that it's much more like liquid than air. A soupy mixture multiple hundred times more pressurized than Earth's atmosphere, which basically lifts up anything and everything. Time to set out. Upon landing on the planet, we were greeted with a windstorm that threw our entire mission into jeopardy. In other words, a pretty average welcome party for Iratis. Our crew is nothing if not determined, however, so we called down a Colossus-craft exocraft. An exocraft designed to take a good buffeting in climates like this. From the cockpit of our new ride, we spied a speck of orange through the dust. Upon closer inspection, we found the origin of this strange glow was an even stranger-looking rock formation. However, there's more to this rock than what meets the eye. Initial scans and analysis of samples brought back to the lab revealed this was actually a unique type of sessile organism, akin to plants, fungi, or coral, the latter being the most similar. On Earth, corals take carbon and calcium and form a chemical called aragonite, which they use to form a structure to build on. These rock-like plants, which are called Amberdrops, use a similar strategy. After seeding themselves, they will take dirt and rock from the ground and repurpose it into a hard skeleton to support themselves in the heavy winds. How do they do this? Well, it would be impossible for them if not for a small species of worm called amberworms, which live inside their bodies. These worms eat the dirt and excrete a substance which the plants turn into a rock-like structure in which to grow. The worms also secrete the yellow amber, which works as a home for the worms and an antibacterial for the amberdrop. Ironically, coral on Earth also share a symbiotic relationship with a smaller organism. They rely on algae to provide energy for them, and in turn the coral provides food for the algae. For the amberdrops, the worms obtain the materials for them, and in return, amberdrops build a specialized home to protect them from the windstorms. As we were capturing footage for the episode, a flit of green emerged from the dust and flitted over to an amberdrop, followed by many others. These are Mosamoths, a species of insectoid creature. They seem to have just woken up from their night-long sleep and are beginning to search for food. They're in luck. Amberdrops happen to be their favorite food source. One thing we noticed is that despite the amber having little to no real food value, the Mosamoths would lap it up by honey, worms and all. After studying Mosamoth biology, we found that the worms have a symbiotic relationship with their hosts. On Earth, having a worm inside your body is generally bad news, as they often take resources such as food from their hosts and use it to fuel their own growth. While structurally, these worms are very similar to parasitic worms on Earth, their relationship with their host is much more mutualistic. While the worms do take nutrients from their host, they also give something in return. The amber these worms produce is actually extremely beneficial to the Mosamoth's structure. Amberworm amber is very thick and highly resistant to heat, which is why it's so effective as a home for the worms when they're inside their amberdrops. Mosamoths will eat up the amber in the hopes of becoming a host for these worms, and then incorporate the amber they produce into their bodies as a defense against the heat of the day or the cold of the night. While wandering the planet, you might encounter some very lightly colored rocks, which will immediately take off and begin to fly. These are not actually rocks, but a special type of beetle-like creature called nutshell beetles, giant insectoids which filled the armored herbivore niche on Iratis. Insects and other arthropods on Earth cannot get very large. The largest arthropods today are the coconut crab, which is the largest land arthropod at 3 feet across and 9 pounds, the Japanese spider crab, which is the widest, which includes its leg span at a good whopping 12 feet across, and the American lobster, which averages about 1 foot and 12 pounds, but has been known to get up to 3 feet and 40 pounds. In comparison, nutshell beetles can get to 6 feet long and weigh up to 200 pounds. That's, hopefully, heavier than you are. They can get so large because they can draw oxygen directly from their food. While observing the beetles, we observed them feeding on rocks which were heavy in iron. They seem to be able to draw oxygen from certain compounds, such as rust. Rust is a combination of iron and oxygen atoms, which occurs when water touches iron. The iron atoms literally pull the oxygen from the water molecule, and thus become an iron oxide molecule. Fortunately for the beetles, there's enough humidity in Iratis' atmosphere that rusting happens relatively quickly, within a week or two at slowest. The beetles will eat the rust and essentially pull the oxygen and the iron apart, and then they use the oxygen to help supplement their growth. Because of this, they can get huge. One main reason arthropods on Earth can't get so large is because of their oxygen requirements, as they do not breathe, per se, like you or I do. Instead, they have holes in their body called spiracles, which allows them to passively breathe by just letting oxygen into their body. However, this is not efficient enough to allow them to get much bigger than they currently are with Earth's current oxygen levels. There was, however, a point in Earth's history where there was enough oxygen in the atmosphere to allow arthropods to grow to huge sizes, as seen in the famous example Arthropleura, or the other famous example, Meganeura, among others. Going back to the nutshell beetles, they have a use for the extra iron too. They can incorporate the iron into their shells, giving them a tough defense against being buffeted around by the wind or bullied by predators or other animals. This may seem like a strange and almost mechanical strategy, but it is not unknown to Earth creatures. A gastropod known as the scalyfoot gastropod, or scalyfoot snail, is a deep-sea mollusk that lives around hydrothermal vents. Surprisingly, it can take iron sulfide from its surroundings and turn it into a metallic defense for its fleshy body, both in its shell and on flakes of chainmail-like armor on its body. In fact, to an extent, all living things require some level of iron in their bodies, as it is what enables our blood to carry oxygen around our body and deposit it to our cells. And it also is the reason why your blood is red. Without iron, life likely could not exist. This may actually be another reason due to the beetles' massive size. The amount of oxygen and iron they consume from rust allows them to have a lot more oxygen and a lot more iron to carry it around their bodies with. Because of this, they can get a lot bigger than Earth arthropods can. That's basically the explanation behind the size of the beetles in a nutshell. While gathering footage of the beetles, the ground began to tremor under our feet. Through the dark, sandy sky, a large shape briefly emerges, but disappears before we can get some decent footage of it. Fearing some kind of strange weather phenomenon, or perhaps worse, we move on. Moving on from the nutshell beetles, we still have a few more creatures to cover on the planet. Flying high above us is a group of Flitterfins, a unique aerial creature akin to swallows on Earth. While at first glance it may look like they have feathers, on closer inspection you can see they actually have a wing much more like a bat or a pterosaur, just much thinner and more streamlined. Their wing shapes are designed for long-range soaring, similarly to the elongated shape of an albatross's wing. During the day, they soar far and wide looking for food. Using the massive windstorms of Iratis as propulsion, these creatures can literally travel around the entire planet fast enough to never see the night. However, if they are caught at nighttime, they are expert burrowers and can dig out a spot to live or rest in a matter of minutes. Flitterfins usually live in large communal nests, which over time Flitterfin colonies dig into the sides of cliffs. Natural caves are also a popular roosting spot, but they are just as happy to literally carve out a place for themselves among the rock and sand. Interestingly, the entrances to their burrows are almost always lower than the burrows themselves, which our scientists think is a way of keeping them from getting drowned in sand. The tunnels into their burrows are also extremely curvy, in just the right way to allow sand and other waste to flow right out. Flitterfins have a naturally excellent sense of smell, which they can use to navigate. Iratis' thick atmosphere and massive winds allow scents to travel for miles, and a Flitterfin can pick up on even the faintest of smells. They use this to make a mental map of scent, which they use to remember where to go for food, shelter, and otherwise. However, nowhere is this sense more important than during the breeding season. When the breeding season begins, males will devotedly follow around the female of their choice, getting as familiar with her scent as possible. Then, a few days later, the females will take off while the males stay behind. A few days later, the males will take off and try to follow their desired female by scent. The first few who find her get to be her mates, while the rest have to wait for next season or somehow find another female. Interestingly, the parents of Flitterfin offspring rarely have a direct hand in raising their young. Young Flitterfins are raised communally by the flock, passed from adult to adult, fed by whoever gets them first. Once they learn to fly, however, the young are forced to learn how to gather their own food. Males in particular do much of the food gathering, while females are better at searching for shelter and defending the colony. They can detect danger from miles away, anything from an incoming storm to a curious xenobiologist. However, Flitterfins do not have the sky to themselves. Flying in large communal groups, Finchbeaks are a small herbivore that feeds widely on nuts and tough plant matter. Much of the plant matter on Iratis is tough and bristly, much like Joshua and yucca trees on Earth. On Earth, not much eats the leaves on these trees because they don't have much nutrition compared to the seeds they carry. It's a similar case on Iratis. Many of the plants are tough and not nutritious. However, this doesn't stop the Finchbeaks. Their beaks are specifically designed to shear through plant matter, cutting the tough leaves of the plants to small pieces. Their saliva is also very strong. The saliva of most animals contains enzymes that begin to digest food in your mouth, but Finchbeaks take this to a whole nother level. Their saliva is strong enough to begin breaking down the plant matter into mush in their mouths. So please, try not to get the saliva on your arm. It will not end well for you.
This is the same guy who was touching the lactonewts in the last episode, right?
Anyways, once the plant matter reaches their stomach, the true work begins. Interestingly, the digestive system of a finchbeak is much more like a cow than that of a bird or a bat, as it has a total of 6 stomachs to digest their food in. While it seems strange that a bird-like creature would have the digestive system of a cow, as with a lot of creatures we've covered, this is not unknown to Earth. The hoatzin, a special species of bird native to the Amazon, primarily eats leaves, and thus requires a second stomach of sorts to digest them. However, unlike cows, they do not chew their cud. Instead, they just let their food ferment in their second stomach, which is actually just their crop. It's similar for finchbeaks. Finchbeaks' 6 stomachs all have a specialized purpose. Each stomach digests a slightly different type of food or part of a plant. For example, one stomach is meant for digesting the hard outer casings of tough plant needles, another is meant for processing the thicker plant matter such as cacti, etc. One other food finchbeaks particularly love to eat are nuts. Finchbeaks will regularly take nuts off the various trees on Iratis and crack them by flying high into the air, then dive bombing into the ground head first, cracking the nut in their beaks. While they don't have the exact same strategy, many birds on Earth employ similar strategies to obtain hard-to-reach foods. Some birds of prey will drop turtles onto sharp rocks to open up their shells, and some crows have learned to drop nuts on a road for a car to drive over and smash them open. As these nuts take much less energy to digest, Finchbeaks will often go after...
Raptor 1, I'm detecting massive biological readings in the vicinity, heading 00923. Lifeform has changed course and is headed directly for your location. Immediate action recommended. Raptor 1, do you read? Oh, Jiminy, Raptor 1?
Raptor 1 party has been hit by an unidentified lifeform. Size rating 10+. Requesting immediate assistance. Over.
Team en route to your location. Over. Hang in there.
The active lifeform is emerging in our position. Requesting immediate action. Over.
Do you read, Raptor 1? Raptor 1!
While exploring the planet, one of our research teams was viciously attacked. A large lifeform was detected approaching one of our expedition parties, and all but destroyed it. At least 17 crewmates went missing, including one of our new interns. Fortunately, we found most of them rather quickly, but when our intern didn't clock in on our radio, we sent out a search team to find them, using one of our state-of-the-art roamers. We eventually spotted them taking shelter in a nearby facility and rushed to their aid. The facility turned out to be co-managed by a Korvax analyst named Abinoslo and a merchant named Ilobop. From what they've told our intern, they use a massive central core to keep away the large creatures, and have managed to survive a long time on the surface because of it. Our scientists may have to invest research into this. Talking to the two managers, they seem to have extensive knowledge about these creatures, which is good news for us. They mention that the local Korvax fear and even worship the large creatures, which are known primarily as Matalons. According to some local folklore, Iratis was once a lush world, but was shredded and devoured by the Matalons, until it was literally ground into a sandy desert. While our scientists and xenanthropologists both agree that this is likely a myth, the intern and I can't help but wonder if there is some truth to this tale. However, we don't have much time for pondering over this. As we look out into the night, we notice that nearly all the native creatures of the planet begin to seek out a place to rest. As we were pondering why this might be, our thermometers began reading a massive drop in temperature, such as I have never seen before. I have never known a world to have such a drastic temperature difference between the night and day sides of the planet. Unfortunately for the fauna, endothermy, or warm-bloodedness, has yet to become commonplace, and as such the creatures here need to literally hibernate for the cold nights. That is, with the exception of one. At night, the skies of Iratis come to life with Raydrifters, the only creature that even approaches nocturnalism on the planet. Raydrifters are unique creatures that are akin to jellyfish on Earth. They drift through the air looking for food to eat on the winds. While the majority are harmless filter feeders, a few varieties are much more predatory in nature. Some varieties will cling to the bodies of dead animals, covering them like stars, coating the night sky, drawing as many nutrients from it as possible. Others, however, tend toward being parasitic, clinging to the surface of any living things that they can find. A notable number of the parasitic varieties seem to prefer nutshell beetles. However, the beetles are protected by their tough iron shell. Perhaps this is why they have the metallic shell in the first place. On returning to our crafts the next morning, the ground rumbles and we are again visited by the creatures, which we now know are the Matalons. However, unlike the night before, they do not attack us. Since it's now daytime, it's much easier to make out their shapes. The massive creature leaps from underground and over the facility, disappearing into the ground without so much as acknowledging us. As we travel the surface of the planet following it, we find many more leaping about, using the thick atmosphere and windy storms to aid their motion. They seem to use the storms as boosts for their migrations, moving from spot to spot. As far as we can tell, they spend much of the less stormy times on the planet sticking their head out above the ground, just drifting it through the air looking for food. They look much more like garden eels during these times, and in fact are functionally not unlike them. Garden eels feed primarily on plankton and small creatures that drift by, and it is similar for the Matalon. They will feed on the smaller creatures of Iratis, especially Raydrifters, basically acting like a giant terrestrial filter feeder, almost like a strange hybrid between a whale and a garden eel. That's when we discovered that they are not the malicious world leaders of the myth, although the myth isn't that far off. These worm-like behemoths are in fact filter feeders, much like whales on Earth. Being so large, their diet consists mainly of every other creature on this planet literally sweeping its mouth through the air to consume as many of the smaller inhabitants as possible. It's likely that, instead of being directly attacked, our exploration team got caught up in such a feeding, or perhaps a migration. Or perhaps our vibrations mistakenly made them think there was a mass gathering of food for them to eat. Sadly, our time on this planet is coming to an end. Other duties and adventures are calling, and the Amanogawa is starting to look brown inside for all the sand we've been tracking into it. Looking back at the planet's surface, I can't help but wonder if there are more secrets this planet has yet to reveal. I wonder if the planet was once a lush world, like the merchant said, or if it was always the way that it was. Perhaps we will return to find out someday. Before I finish the video, I want to thank you all for watching this episode of the Amanogawa Chronicles, despite how long it took me to get it out. Real talk for a second, I've just finished my first semester of college, and as of writing and reading the script, I'm just starting my second, so I've not had as much time to devote to the project. I want to thank you for your patience and your kind comments. I honestly can't believe I've gotten as much traction as I have, little though it may be, and I honestly can't thank you enough for just watching the video. The Amanogawa thanks you for stopping by, and reminds you to always look for the beauty in life. Stay safe and never be afraid to explore. I hope to see you next time.